The dashboard says 247 findings, including 12 criticals. That looks like an emergency. But the first critical belongs to a retired lab image, the second is unreachable from the internet, and the third is already fixed but has not been verified. One medium finding is on the public login server and appears in a known exploited catalog. The color is not the decision. Context is. By the end, you will know how to read a vulnerability scan without treating every red badge as a breach. We will triage a fictional local report, find the one item that deserves immediate review, catch a false assumption, document the decision, and verify remediation. The method works across scanners because it focuses on evidence instead of one vendor interface. Start with the right mental model. A scan finding is a hypothesis supported by some detection evidence. It may come from a software banner, an authenticated package inventory, a configuration check, or a probe response. Those methods do not have equal confidence. A finding is not proof of exploitation, and a critical severity is not automatically your first patch. It is a prompt to investigate. Use 4 lenses. Asset asks where the issue lives and who owns it. Evidence asks exactly why the scanner raised it. Threat asks whether exploitation is known or likely. Impact asks what a successful exploit could change in your environment. Think of CVSS as the weather forecast. It describes the storm's technical strength. Your asset exposure tells you whether the windows are open. Our demonstration is a realistic simulation. The export contains fictional vulnerability identifiers and 3 owned lab assets using documentation addresses. Lab Web 01 represents an internet-facing login service. Lab DB01 is internal and segmented. Lab Archive 01 is an offline image. We will not scan a target, run an exploit, change a system, or use real customer data. We are only reading a local JSON report. The headline count is 247 rows. Grouping by asset reveals 3 systems and 11 unique findings. Many rows repeat because one plugin maps to multiple identifiers or because the same condition appears on several ports. Never promise leadership that 247 patches are required until you understand how the scanner counts. Preserve the raw export, then normalize it into one reviewable record per asset and condition. Select Lab Web 01. The inventory says production, internet-facing, and owned by the identity team. Lab Archive 01 is offline and scheduled for deletion. Asset state immediately changes urgency, but it does not erase a finding. Record the evidence for the exception and its expiration date. An offline system can return to service by accident, so exceptions need owners and review dates. Open the top web server finding. The evidence says an authenticated package inventory observed version 4.2, while the fictional vendor fix is 4.2.3. That is stronger than a banner-only guess. Check the scan timestamp, authentication status, port, protocol, and exact detection text. Generic remediation advice is useful, but the evidence tells you whether the finding actually applies. Now add threat context. CVSS describes technical characteristics and potential severity. CISA's known exploited vulnerabilities catalog identifies vulnerabilities with evidence of exploitation in the wild. EPSS estimates the probability of exploitation activity for a CV over the next 30 days. These signals answer different questions. None replaces asset ownership, reachability, detection confidence, or business impact. Our fictional medium finding moves to P1 because the public identity service is affected, the evidence is authenticated, and the simulated threat feed marks active exploitation. A critical on the offline archive becomes P3 with a documented disposal action. A high on the internal database becomes P2 because it is confirmed and valuable but segmented. The queue is defensible because every position has visible reasons. Here is the common mistake. The analyst sorts descending by CVSS and sends all criticals to the infrastructure team. The exposed identity finding waits behind an offline image. The correction uses context gates. First validate the finding, then check exposure and exploitation, then consider impact and available controls. Severity remains important, but it no longer makes the decision alone. Suppose the scanner reports an old library, but the package manager shows the fixed backported build. Do not click false positive because the patch team disagrees. Compare the plugin logic with vendor guidance, capture the package version, document the backport, and ask the scanner owner to review. If you suppress the result, add an owner and expiration. Weak evidence becomes a question, not an excuse. For the public service, the fictional change plan updates the package during the approved window. The ticket records the owner, deadline, affected service, rollback step, and verification method. If patching is not immediately possible, mitigation might reduce exposure or disable the affected feature. Risk acceptance is a business decision with an expiration date, not a permanent security team label. After the simulated update, a targeted remediation scan checks the same plugin on Lab Web 01. The new evidence shows the fixed version, the finding is absent, and the service health check passes. This is the moment the ticket can close. If the scanner still reports the issue, investigate stale agents, incomplete authentication, multiple installations, or a failed change. Verification converts an intention into evidence. On your next authorized scan report, choose one finding and write 7 lines: asset, evidence, threat context, impact, owner, action, and verification. If one line is unknown, that is your next investigation step. Do not panic at the total, and do not dismiss the scanner. Turn the output into an evidence-backed queue. The complete triage worksheet is available on CipherVibe.com.